Okay, so I'm going to do number 37 on section 2.6 because it requires the use of the sandwich theorem or squeeze theorem, as in other books is known. So let's just remember what kind of functions we're dealing with in here. Cosine of x, you know that it oscillates between -1 and 1. So as x approaches infinity, it could be either -1 or 1 or any other value. So actually the limit does not exist as x approaches infinity. And then in here we have e to the -2x. So let's remember what this transformation from the parent function is. So I have the parent function y equals e to the x. So having a 2x instead of an x just means that it's going to be dilated by a factor of 2 on the x-axis. So the appearance is pretty much stays the same. In here I have the special point 0, 1 still, but it is just gonna be shrinking on the x direction, so that's fine. It still looks the same. So how does y equals e to the -2x looks like? And remember, if it's affecting the x directly, it's not like this negative is outside. It's affecting the x directly, so it's not a reflection over the x-axis, but it's a reflection of the y-axis. So this is how it's gonna look like. So now you can see as x approaches infinity, the limit of this is 0. So we are going to show that the limit of this product is actually going to be 0. But please do not split it, because I can't say that the limit of this product is the product of limits, simply because the limit of this number of this function does not exist. So I can't split it with having one limit not existed. So I can't apply the product property here. I have to keep it as only one function. Okay, so to apply the sandwich theorem, and I know that you will remember this graph. If I have a function for which I'm trying to find the limit, and then I define a function that is pretty much greater everywhere else except for that point, it could be equal at that point. And then I find another function that is less everywhere else except for that function, for that particular x value. Let me call f, and this one let me call g, and let me call h. I'm trying to find the limit of the function h for this particular value. So if I know that f is greater everywhere else and g is less everywhere else, and I know the limit for f and g and both of them match, then I can say that the limit for h is also that value of the limit. It is the same for that particular point. So I'm trying to
Good afternoon, students.
So this theorem is fairly easy, especially when we have functions like sine and cosine in them, because that's the way we're going to start. I know the cosine of x varies between 1 and -1, and that is a fact of the cosine. Then what does this cosine of x need so that the function resultant is like this? Well, I just need to multiply it by e to the -2x. So I'm going to go ahead and multiply everything in my inequality by e to the -2x. So this will be negative e to the -2x, e to the -2x cosine of x, and then 1 times e to the -2x is e to the -2x. Okay? So now this is the function that I'm interested in finding the limit of. So now this is the function that is always lower, and this will be the function that is always higher. So I'm gonna find the limits of these two functions, and if it happens to have the same limit, then I can say that the limit for this function is actually the same answer. So the limit as x approaches infinity, or negative e to the -2x, is let me go back to my graph. This is how e to the -2x behaves. How does negative e to the -2x behave then? This is just a reflection over the x-axis. So if the original behaves like this, then the other will behave like that. So again, as x grows very large, the y's are approaching 0, so this limit is 0. Now the limit as x approaches infinity of the other function of e to the negative 2x, we saw that that was 0 as well. I mean, I can see it in the graph right here. It's also approaching 0. So the limits of these two functions is 0. Then I can say by sandwich theorem, if the limit of the function on top matches the limit of the function on the bottom, then the one in the middle is also the same. Of e to the negative 2x cosine of x equals 0 as well, just because these two are 0. If they were different, then I couldn't apply this theorem. Remember that the name of this theorem is also squeeze. Okay, could be sandwich or squeeze.